Hi everyone, I am Dr. V.S. Nishok from EC Department, SNS College of Technology. Here we have gathered to discuss the topic operating point of BJT from the subject Electronic Circuits. So this is the outline of our video, which starts with need for proper amplification and distorted output signals, setting the correct cue point, what is cue point, characteristics of the good cue point and its practical applications. So before going to cue point, we can see what is the need for proper amplification. See, in real world situation, many electronic systems like microphone, mobile phone, audio amplifier, so everything deals with the weak signal. So the sensors also providing the weak signal, so which should be amplified properly before going to the next step, next process. So that is the main objective here. So we need the faithful amplification without disturbing the original information of the input signal. So that we are improving the signal strength. That is much needed here. Here, if the signal the input signal is not properly amplified, then it results in the distorted output signal. Distortion means clipping in the original signal or any loss in the output information. So that is called as a distortion. So due to the distortion, the communication will be communication quality will be reduced and incorrect amplification is done. So these are the main drawbacks of the incorrect amplification. So we need the proper operating condition for the proper amplification. So for the proper operating point, we need to set the correct cue point. So the cue point should be kept properly in the DC operating point. So that is mainly in the active region, which gives the full swing of the signal, so which results in the good output. So that reduces the distortion. So what is cue point? So cue point is referred as a quiescent point. So that is means the at rest or no signal. So without giving any input signal, we need to have a starting point that is called as a cue point here. So it is defined by two parameters called collector current IC and collector emitter voltage VCE. These signals are measured before input is given. These parameters are measured before the input is given. For example, a car is standing in the traffic signal, so it is having a starting point, some starting point. So that is same thing is applicable here. So before giving any AC input signal, there is a starting point of the transistor. So that is the DC condition. So that is called as a operating point or operating condition. So location of cue point on load line. So cue point lies on the DC load line, so which should be specifically at the center point, that is mentioned as an active region, so that the signal will swing properly ups and down, so which results in the full swing in the output. So that is much needed here, and which produces the actual output without any distortion. So this is best for amplification, and incorrect cue point leads to the signal distortion. So coming to the characteristics of the good cue point. So the good cue point should have the following three characteristics. The cue point should locate in the active region and stable with variations in the temperature and provides the maximum signal swing. So that is best applicable here. So if this 3 point matches, so the faithful amplification takes place in the transistor. So coming to the practical applications of the transistor with good operating point. So we can say audio amplifiers, radio receivers, sensor amplifiers, communication circuits, etc. These are all used in the various real world electronic systems. this is the time for summarizing. So we have started with need for proper amplification, and we have seen the what is load line, what is Q point, and what is good Q point, and what are the practical applications, etc. So this is the time for assessment. A good Q point should lie in the active region. So if it is in saturation or cutoff region, the output swing will distorted. So it should be lie in the active region. So improper Q point causes distortion, loss in the signal output information. So coming to the references. So here these are the books and websites we referred for this video. Thank you all for joining the video. We can join in the next video.